We are starting a new chapter, chapter 3. It's on light waves, but light waves are not just visible light waves. Light waves are a whole gamut of things from the invisible to the visible and then back to the invisible again. But these types of waves are different in the fact that they travel as transverse waves. So they vibrate an electric and magnetic field, and they can move through space at the speed of light. So if you're thinking, what kind of stuff comes from the sun? This is it. Electromagnetic radiation comes from the sun. So anything that comes from the sun travels through space, hits our atmosphere, and comes on in. And it travels as transverse waves. And remember, transverse waves are just kind of the up and down ones. The ones that sound waves travel at, they travel as transverse. I'm sorry, not transverse. They travel as longitudinal waves, which are in and out, in and out. Light waves travel kind of up and down, up and down. They are produced by changing electric and magnetic fields. So when we learned about magnetism and electricity, we also talked about electromagnetic waves last year. And you can see in this picture down below that this kid holding the umbrella is being bombarded by waves. His dog, the plants, the earth, whatever. So there's waves constantly bombarding us. We don't feel them, obviously, but because light travels all the time in every place, they're constantly being bombarded by visible and invisible waves. Okay, so electromagnetic radiation is transferred through space by what we call electromagnetic waves. So the radiation that hits there from the invisible to the visible is electromagnetic radiation. The speed of light is 300,000 kilometers per second, so it travels that quickly. It takes about 8 minutes from the sun to hit Earth's atmosphere, so we see it. And you can see that there's this straight line going through. That's the direction of the wave, but it's traveling kind of in a three-dimensional way, so up and down and back and forth. So it's got the magnetic field and the electric field. And so like the electromagnetic radiation, you've got both types of fields there as it travels through. Some interesting things, because it travels in kind of two different directions, it's hard to block out completely. So two important properties of electromagnetic waves is they travel as waves and as particles. We'll talk about these things called photons, which is how they travel. Polarized light that passes through a polarizing filter. So if you've ever worn sunglasses before and you don't see as bright of light when you wear your sunglasses, that's because they're traveling through polarizing filters. And what a polarizing filter does is it blocks one direction of the wave, so only part of the wave gets through. So they kind of almost, they're like little slats, and so those slats only allow one direction of the wave to get through them. So they can block some of that, which is why when you wear sunglasses, you might even see, if you buy a pair of sunglasses, it's like, it might say polarizing filters, or it might say polarized sunglasses. It's because it's blocking out half of the rays of light that can enter there, which is why it's blocking out some of the harmful stuff too. And then it's because that light travels in basically two different directions, back and forth and up and down. Okay, so this whole idea behind electromagnetic waves is this thing called the photoelectric effect. Albert Einstein is the guy who kind of developed this whole idea. This is because these electrons can be knocked out of place in the electromagnetic spectrum during that electromagnetic radiation, and those packets of light that can be knocked out of the waves are called photons. So they're packets of light energy that can be knocked out of the electromagnetic spectrum. So they are knocked out. They travel as both waves and as particles. That's what the kind of interesting thing is about light waves. And again, most of them are invisible. We only see a very, very small part of the spectrum of light that hits our atmosphere and hits our Earth. The way it travels is kind of interesting. This is the end of the first section in Chapter 3. It's all going to be on light waves. We're going to talk about more specifically the parts of the electromagnetic spectrum in the next section. You have homework on this in your packet, and you can also find it on Pause Learning. Enjoy!